Alright gang, let's try number 15 from section 4.5. So when you have a limit going to infinity on a fraction, you have to look at whether it's top heavy, bottom heavy, or equal in degree in terms of its exponents of the highest degree. I went over this in lecture, so make sure you're going to infinity on a fraction, so it's the exponents, the highest exponents of each side, which determine the limit. Alright, so that's the first thing you always go in for. So since this is going to infinity, I'm going to look at the degree of each. So the degree of the numerator is 3/2, because that's the highest exponent. The degree of the denominator is 2. So when I compare the degrees, the denominator has the higher degree. So therefore, in the lecture, I called this bottom heavy. When the denominator has the higher degree, the fraction will collapse to 0. Because what's happening is the denominator is going to get bigger faster than the numerator, which then is going to collapse it to 0. Alright, so I called this in class bottom heavy, just to give you something to try to remember it by. I'm going to do it again. Now the degree of the numerator is 3/2. The degree of the denominator is 3/2. Alright, now this is the case where they're equal in degree. Make sure you're going to infinity. This rule only works when you're going to infinity. So we're equal to in degree of a fraction, so that means that we need the coefficients of the leading terms. Now the leading terms will be the numbers in front of the highest degrees. So that would mean that I take this one because this is the higher term, not this. This guy is. So remember, they might not be in order. You have to take the captain, the coefficient of the captain from each side. So the highest term is this one, so I need the coefficient of that. The highest term is this one. So this is going to end up being -2/3. So again, when they're equal in degree, it's the ratio of the coefficients. So I have a -2 over +3. And again, just one more time, the leading coefficients may not be in descending order. You sometimes have to hunt for them. Alright, let me look at what we got here. This is degree 3/2. This is degree 1. Alright, so at this point, you haven't actually learned how to find the answer to this case. So what I'm going to do is I'm going to tell you what you should be able to write as to this point. You're not going to be able to get the specific answer yet because I haven't taught the lecture on this part yet, but in general, this is top heavy, right? This number is bigger. So in general, you know that if it's top heavy, you know that you can write DNE. Now that's not technically the best answer, but let me write that for starters. So I've taught you that if it's top heavy, the limit doesn't exist. Now the problem is doesn't exist means that in this case that either the function is running off to positive infinity or negative infinity. So right now, if you can just get this part, I'm going to be happy with you. Moving forward, there is actually a better answer to this, and I will expect you to be able to get the better answer. So I'll just say it briefly now, see if you can understand it. If you don't, we're going to come back around, okay? So when you go to infinity, the only thing that has power are the strongest terms. So this term is weak, this term is weak. So the highest degrees have the most power. So the things that have the most power here is the 2x to the 3/2. That's the most powerful term in the top, and the 3x in the bottom. Now, if you notice, if we put in infinity, it's still infinity over infinity. It's still top heavy. We still have a problem. So one of the techniques then would be to reduce this. So if we reduce this, this is 2/3. This is going to be x to the 1/2. So if we reduce this, and you have to watch your sign. So you're putting, oh, I have to watch my sign. Excuse me, I missed that guy. I crossed him out and I don't see him. That's really important. That's going to screw me up. I had to catch that. Signs are important when you go to infinity. All right, so what's going to happen is that you can see if I reduce this that it's going to be 2/3 times the square root of infinity, which is infinity. What gets tricky is that it's going to be, once you put infinity in here, and you take the square root of it, the square root of infinity is infinity, but now infinity times -2/3 is negative infinity, and that's the tricky part. So again, at this point, if you just get to here, I'm really happy with that. If you can sort of start to plant the seed and mull this over a little bit, that'd be great, but we are going to hit this coming up very shortly back in chapter 2. All right, gang, that's it on this one. Catch you. Bye-bye.